Today's topic of discussion is peephole optimization. This presentation is prepared by Sifat Ahmed and Hamza Ijaz. Before understanding peephole optimization, we need to understand what is optimization in compiler construction. Optimization is a program transformation technique which tries to make the code much efficient, as a result deliver high speed. Efficient means consuming less CPU and memory resources. The output code must not change the meaning of the program. Now let's discuss what is peephole optimization. Peephole optimization is a technique of optimization that is performed on a small set of compiler-generated instructions. This small set is known as peephole or window. Peephole optimization involves transforming the small set of instructions to an equivalent set that has better performance. This technique works locally on source code to transform it into an optimized code. It is a short sequence of target instructions that can be replaced by shorter or faster sequenced instructions. It examines a few instructions and transforms them into less expensive or more efficient instructions, such as multiplication of x by 2 into an addition of x with itself. X multiplied by 2 equal to x plus x. They both give the same answer, that is 2x. Now let's discuss techniques involved in peephole optimization. There are four techniques involved in peephole optimization. Number 1, remove redundancy. Number 2, eliminate unreachable code. Number 2, flow of control optimization. Number 4, algebraic simplification. Number 1, remove redundancy. To understand the removal of redundancy, I'm going to take this least optimized code as example. The function, I've created a function that takes one number as argument and returns a number that is multiplied by 2 or doubled. Uh, I've taken two integer numbers a, b, and a is given the value 2 and b stores the product of number when multiplied by 2 and returns the b. Now we can optimize it uh, like this. In here I've taken one number as argument and returned that same prototype is used for function where the number a, it contains only the product and 2 is not stored anywhere. This will reduce the use of memory and returns a that contains the product. Now we can further optimize it if we store a in uh, 2 in a and then return the product. But it can be further optimized if we directly uh, return the product of the number multiplied by 2. Now let's talk about eliminating unreachable code. It removes the part of code that is not accessed due to unconditional jump or return statement. For example, there is a function which takes two arguments x and two arguments of type number type int x and y and returns an integer. This return x plus y states that we are returning the value, the sum. Cout value of x will display the value, but this code is unreachable as the control is already transferred on this previous instruction of return. Third technique is flow of control optimization. When a piece of code jumps back and forth where no significant task is performed, these instructions can be eliminated. For example, in given code, that is move R1 to R2, go to label 1. Label 1 gives the instruction go to label 2. L2, I've named labels L1 and L2. L2 performs the increment. Since we can see that L1 performs nothing and just transfers the control to L2, it is useless due to no action performed. We can optimize it by move R1 R2 instruction followed by go to L2 and L2 performs the increment. There is no need of involving label L1. Now fourth and last technique is algebraic simplification. Under certain situations we can simplify the algebraic expressions. For example, z equal to z plus 0. We can replace z by itself as there is no change by adding 0 in a variable. Z equal to z plus 1 can be simplified or simply replaced by increment z instruction as we are only incrementing the value. Thank you.